The world's first AI nuclear warhead inspector, China's groundbreaking leap in arms control verification. In an era of rapid technological evolution, artificial intelligence, AI, has begun to penetrate even the most sensitive sectors of national security. In 2025, China unveiled the world's first AI-driven system capable of verifying nuclear warheads, a historic development that could redefine arms control protocols globally. Developed by the China Institute of Atomic Energy, CIAE, this system offers a novel approach to nuclear verification, navigating a maze of secrecy, geopolitical tension, and technical complexity. This speech explores the implications, innovations, challenges, and geopolitical context surrounding China's AI nuclear inspector. The global nuclear arms race has persisted for decades, with superpowers like the United States, Russia, and China engaged in an ongoing contest of strategic superiority. Efforts to curb this proliferation have yielded landmark treaties such as the Non-Proliferation Treaty, NPT, Strategic Arms Reduction Treaty, START, and Comprehensive Nuclear Test Ban Treaty, CTBT. However, verifying compliance with these treaties remains a formidable challenge due to the highly classified nature of nuclear arsenals. Traditional verification mechanisms rely on physical inspections and electronic systems embedded with information barriers. These techniques, although effective to an extent, suffer from limitations that can hinder mutual trust among nations. For instance, human-led inspections are susceptible to bias, logistical complications, and political constraints. Furthermore, intrusive inspection protocols can reveal sensitive military technologies, making countries hesitant to agree to thorough inspections. The introduction of an AI system into this domain, therefore, signals a monumental shift that promises not only technical efficiency but also greater transparency and security. Unlike traditional methods, AI-driven verification can operate with higher consistency, analyze massive datasets in real time, and function with minimal human intervention, reducing the potential for errors or manipulation. The AI verification protocol. How it works. China's AI system is formally known as the Verification Technical Scheme for Deep Learning Algorithm based on Interactive Zero-Knowledge Protocol. It integrates deep learning with advanced cryptographic techniques to verify nuclear warheads without disclosing sensitive design information. This concept is rooted in a protocol co-developed by Chinese and American scientists over a decade ago. The AI system's core innovation lies in its ability to differentiate genuine nuclear warheads from decoys. Researchers employed Monte Carlo simulations to generate millions of synthetic warhead components, some real and some fake. A deep neural network was then trained using neutron flux pattern data derived from these simulations. The result was a model with extremely high accuracy in detecting real warheads. To further protect classified information, the CIAE team introduced a novel masking mechanism, a 400-hole polythene wall that filters neutron radiation. While it scrambles geometric data of the warhead, it still allows essential radiation signatures to pass through. Thus, the AI system can make reliable verification decisions without ever seeing the actual warhead. This technical advancement allows for verification under a zero-knowledge framework, an approach whereby a party can prove a statement is true without revealing why it's true. This innovation is critical in arms control, where the balance between verification and secrecy must be meticulously maintained. Surmounting technological and political hurdles. Developing this system was not without its challenges. The CIAE research team had to overcome three significant barriers. Training with sensitive data. Due to the highly classified nature of nuclear warheads, accessing real data posed enormous risks. The team had to develop methodologies that would not compromise national secrets while ensuring the AI model was robust and accurate. Securing military confidence. Convincing the Chinese military that the AI system would not leak technological secrets was a considerable feat. Trust in technology, especially one involving AI, requires rigorous validation and assurance protocols. The military demanded airtight guarantees that the data used, processed, or output by the system would not fall into the wrong hands. International acceptance. The final hurdle lies in persuading other nuclear powers, especially the United States and Russia, to transition away from Cold War-era verification techniques and adopt this new model. Skepticism, trust deficits, and geopolitical rivalry remain formidable obstacles. For AI verification to become a global standard, multilateral endorsement and joint development would be essential. Addressing the dual-use dilemma. AI's application in nuclear verification raises the broader issue of dual-use technology. While this system is designed to promote disarmament and compliance, there exists the latent risk of its misuse for espionage or subversion. The CIAE acknowledged this concern and proposed sealing the deep learning software before inspections, with joint coding and training by all parties involved. Furthermore, the AI inspector operates under a zero-knowledge proof framework, ensuring that no sensitive data is learned or transmitted. This cryptographic foundation is key to gaining international acceptance, as it theoretically eliminates the risk of technology leakage. However, the potential for misuse remains. Dual-use concerns are not unique to AI. They are prevalent in many scientific disciplines. Yet, the autonomous and adaptive nature of AI heightens the stakes. A rogue actor could, in theory, repurpose the verification AI to reverse engineer warhead designs or manipulate inspection outcomes. To mitigate these risks, the CIAE suggests stringent international oversight and secure hardware modules that prevent unauthorized access. Strategic and geopolitical implications. The deployment of an AI warhead inspector arrives at a time of heightened global tensions. Despite repeated efforts by U.S. President Donald Trump to renew disarmament talks, China has remained cautious, citing its smaller nuclear arsenal and concerns over outdated verification methods. China's estimated 600 warheads pale in comparison to the United States' 3,748. However, Beijing argues that modernizing verification mechanisms is a prerequisite for meaningful negotiations. By demonstrating leadership in arms control technology, China positions itself not only as a responsible nuclear power but also as a technological innovator. This move may compel other nuclear nations to accelerate their own AI research, potentially sparking a new form of arms race centered around intelligent verification systems. It also raises questions about the role of AI in broader defense infrastructure, especially given its potential integration into autonomous weapons systems. Moreover, China's unveiling of the AI inspector could alter diplomatic dynamics. For instance, smaller nuclear states or those seeking disarmament verification mechanisms might look to China for support or partnership, challenging the traditional dominance of Western powers in arms control diplomacy. Ethical considerations and the path forward. China and the United States have both declared that AI will not be used to make nuclear launch decisions. Nonetheless, the broader militarization of AI remains a deeply controversial issue. The unveiling of this verification system underscores the need for robust international frameworks that govern the ethical use of AI in military applications. The CIAE team advocates for collaborative development and oversight of such systems, recommending that international bodies such as the International Atomic Energy Agency, IAEA, and United Nations play a central role in setting standards. Transparency, mutual inspections, and sealed algorithm protocols are essential to build confidence and avoid escalation. Ethical AI in arms control must adhere to principles of accountability, transparency, and non-maleficence. Stakeholders must ensure that these systems do not perpetuate inequality, provoke arms races, or undermine human decision-making authority. Scientific and technological milestones. The creation of this AI system is a testament to China's scientific prowess. It draws on decades of expertise in nuclear physics, led by luminaries such as Yu Min, the so-called father of China's hydrogen bomb. His work laid the foundation for innovations that now include intelligent verification systems. The use of deep learning, neutron flux analysis, and cryptographic protocols represents a convergence of multiple scientific disciplines. It illustrates how modern AI can be harnessed not just for commercial gain, but for addressing some of the world's most critical security challenges. Beyond nuclear verification, these technologies could find applications in areas like nuclear waste monitoring, environmental safety, and even medical imaging. China's leadership in this domain may catalyze a broader wave of scientific collaboration and innovation. Public perception and media coverage. The announcement of this breakthrough has garnered significant international media attention. The South China Morning Post, among other outlets, emphasized the potential for this technology to reinvigorate stalled arms control talks. Public opinion remains divided, with some hailing it as a step toward global peace, while others view it as a strategic maneuver to gain leverage in geopolitical negotiations. The lack of transparency surrounding the AI's training data has fueled skepticism. Critics argue that without international peer review, the claims of accuracy and security remain unverified. Supporters counter that the very nature of nuclear technology necessitates some level of secrecy. Discussions on platforms like X, formerly Twitter, Reddit, and LinkedIn show a wide range of opinions. Scientists generally laud the innovation, while security analysts call for careful scrutiny. Civil society groups urge greater inclusion in the dialogue, stressing the importance of public accountability. The road to international adoption. For the AI verification system to gain global traction, it must undergo rigorous international evaluation. This includes testing by third-party researchers, pilot programs under the auspices of the IAEA, and potential adoption in bilateral or multilateral arms control agreements. China has reportedly expressed openness to collaborative trials, provided mutual safeguards are in place. A potential roadmap could involve a phased integration where the AI system is initially used in less sensitive verification scenarios, gradually scaling to full-scale inspections. International acceptance will also hinge on creating common AI standards. The development of an AI Geneva Convention for arms control, where norms, legal frameworks, and operational procedures are clearly defined, may be essential. A turning point in global arms control. China's development of the world's first AI nuclear warhead inspector represents a significant milestone in the quest for global security and arms control. By merging cutting-edge AI with cryptographic safeguards, this system offers a new path forward that balances transparency with secrecy. The road ahead is fraught with challenges, technical, ethical, and political. Yet, the promise of a safer, more verifiable world may well hinge on our ability to integrate intelligent systems into the most guarded domains of international relations. In doing so, we must remain vigilant, collaborative, and committed to the ideals of peace and mutual respect. This development not only positions China at the forefront of AI innovation in national security, but also opens the door to new conversations about how humanity can responsibly govern its most powerful technologies. The AI nuclear inspector is more than just a machine. It is a symbol of a potential new era in global cooperation, where science and diplomacy meet to ensure the safety of all humankind.